Our next lesson is called Absolute Value Functions Day 2. We'll start with the opening exercises. Determine at least 5 solutions for each 2-variable equation. Make sure some of the solutions include negative values for either x or y. So at this point, I'd like you to pause the video and try the opening exercise, then resume the video when you're ready to go over the answers. Okay, at this time, you have completed the opening exercise, so let's go over the answers. For part A, y equals the absolute value of x. I have the coordinates -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Obviously, there are other coordinates that would also work. For B, I have -2, 7, -1, 6, 0, 5, 1, 4, and 2, 3. Again, other coordinates would also work. And then for C, 2, -2, 1, 1, 3, -3, 0, 0, and 2, 2. So remember what you're doing here. You're thinking to yourself, okay, I'm going to pick an x value for A and B, probably would be the best one to do. If I pick an x of -2 in part A and I plug it in, the absolute value of -2 is 2. That's how I got the y value. Let's look at this one, -1, 1. I put -1 in for x right here. The absolute value of -1 is 1. That's why that's my answer for y. You can also use your graphing calculator to get tables of values in order to get solutions as well. I do want to point out in part C, it would make more sense to pick y values. So I actually started by picking a y value of -2, plugging it in for y. The absolute value of -2 is 2, and then I wrote down my x values. So here I would have picked x if I was actually plugging in or just using my graphing calculator. Here I would have picked x, here I would have picked y. Another note about part C is if you actually go and graph this, this ends up not being a function, which we will show down below. As well as here, we have, notice in the other ones, x's could be negatives and y's were all positive. Here, the y's can be negative and the x's are all positive. So here we also want to write that x cannot be negative. For our first example, we're going to take parts A and C and create graphs of the solution set of each 2-variable equation. So let me show you what you can do with your graphing calculator in order to graph these. If I want to find out what the graph of y equals the absolute value of x looks like, I'm going to type y equals screen, and I need my absolute value button, which is under math. So I will go to the math key. I will hit the arrow to the right to go over to number, and you can see choice 1 is absolute value. When I pick that, it takes me back to the y equals screen and gives me the set of bars that I need, where I can then type in my x, which is right next to alpha. Now when we go to graph this, we hit zoom, choice 6 for standard, and you can see this V-shaped graph. If we want to look at the table of values, remember we go second, graph, and that gives us the table. Now for us, we already probably either have done that or found coordinates that work, so we're just going to take the coordinates that we see up above and plot those. So -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So you can see the pattern. We have a line going this way, and we have a line going this way to give us this V-shaped graph. We're going to label it with y equals the absolute value of x. Now make sure you use a ruler so that you maintain this slope of 1 on this side and slope of -1 on this side. We are going to graph y equals the absolute value of x minus 5, which we have coordinates up above we can use. -2, 7, -1, 6, 0, 5, 1, 4, 2, 3. It looks like a line. So let's go back to our graphing calculator and take a look. I'm going to go back to my y equals screen, and I'm just going to continue to type here -5 right inside the absolute value. I'm going to hit zoom, 6 for standard, and you can see that over here you have a drop where it then goes back up to being looking like a V shape. So if I actually go second, graph, and look at my table, I want to take and see where it turns back around. I see it right there. See how it goes 3, 2, 4, 1, 5, 0, 6, 1. So we need to make sure we get down to 5, 0 and then pop back up to 6, 1. So here's 5, 0, here's 6, 1. So now we know we're going to connect these to make that side of the V and this side to make that side of the V. And then we'll label it y equals the absolute value of x minus 5. So now we'll look at part C. So we're going to go ahead and plot these points. I have 2, negative 2. I had 1, 1. I had 3, negative 3. I had 0, 0. And then 2, 2. So you can see we have that same V shape, but it's turned on its side. And this is labeled with x equals the absolute value of y. Now underneath, we're going to write a brief summary comparing and contrasting the 3 solution sets and their graphs. So let's start with A. A, we definitely have a V-shaped graph. We have the same thing for B. That's something that they have in common, a V-shaped graph. In C, however, it is not V-shaped. That V is tilted on its side. So I'm going to say this shape graph. So now let's talk about function, not a function. This would be a function, A. B is also a function, so each input has one output or it passes the vertical line test. This one is not a function. You can see an input of 1 has an output of 1 and negative 1, or it fails the vertical line test. Now let's look at domain and range. The domain for graph A, which means, remember, I'm going to try to pinch it, making my hands look like y-axes, and I'm not allowed to do it. It's going to keep going up and out. So the domain is all real numbers. Here, the domain is also all real numbers. In our last one, my domain is different. It goes from, if I start to pinch from this side, I can pinch all the way up to 0. So this one is x is greater than or equal to 0. If I look at the range now, the range here, if I try to pinch, I can pinch all the way up to 0. So y is greater than or equal to 0. For B, it's the same exact thing. And then for C, when I go to try to pinch, I cannot. It's going to continue to go out and up. So I end up with the range here being all real numbers, which makes sense. The x and the y switch positions, and therefore the domain and the range switch positions. And one last thing to mention about graph B. In graph B, it actually is translated, which means it slid 5 units right from graph A. So if we take a look at graph A and we actually count 1, 2, 3, 4, 5 over, that gives me this graph over here. So just a special note about that. For example 2, it says f1 of x equals negative x for x is less than 0. So all the x values that are less than 0, we're going to use f of x equals negative x. Then we're going to let f2 of x equals x for x is greater than or equal to 0. So all the numbers that are 0 and up for x, we are going to use f of x equals x. We're going to graph the functions f1 and f2 on the same Cartesian plane, that means coordinate plane. How does the graph of these two functions compare to the graph of y equals the absolute value of x? So remember, we're going to use f1 of x when x is less than 0. So we have to pick numbers that are less than 0. I like to go in an increasing fashion here, so I'm going to go -4, -3, -2, and -1. And remember, here we're using f of x equals negative x. If you look at this as being mx plus b, this has a slope of -1 and a y-intercept of 0, and we're only going to graph it when x is less than 0. Now you can use your graphing calculator to help you do this. Y equals, and I will hit -x. I will hit zoom 6 to get an idea of the graph, but then I'm going to look at the table of values. And I want to go up and find the values that I chose. which was -4. So I know it's -4, 4, -3, 3, -2, 2, -1, 1. So I'll write 4, 3, 2, 1. We will graph these. So -4, 4, -3, 3, -2, 2, -1, 1. And we'll stop there. Now we'll look at the second piece of the graph that we're going to use when x is greater than or equal to 0. Remember here we're going to use f of x equals x, which means I have a slope of 1 and a y-intercept of 0. And I can use numbers 0 and up. So I'll do 0, 1, 2, and 3. We can go back to our graphing calculator. So here we're going to clear out y equals -x and just do y equals x. We will hit zoom 6 to get a picture of that. Then look at the table by going second graph. And we know we're starting at 0, so we'll go ahead and scroll down. So we see we have 0, 0, 1, 1, 2, 2, 3, 3. So 0, 0, 1, 1, 2, 2, 3, 3. So we have 0, 0, 1, 1, 2, 2, 3, 3. So look what happens. When we put these pieces together, here's that piece, which was f2 of x. And if I connect these, here's f1 of x. I'll take a look at that. Couldn't I just trace right over both of these with one single thing for the absolute value of x? So we're going to put a little note here. This graph is the graph of f of x equals the absolute value of x in pieces. So it's the same thing, it's just that we broke it up into two sections. So you have a definition underneath. The absolute value function f is defined by setting f of x equals the absolute value of x for all real numbers. Another way to write this is as a piecewise linear function. We're going to be talking more about piecewise functions later in the chapter, but essentially you just break the graph into pieces and graph the pieces separately. That's exactly what we just did in example 2. We graphed -x when x was less than 0 and positive x when x was greater than or equal to 0. Let's do an example of graphing again of absolute value function. Have g of x equals the absolute value of x minus 5. We're going to graph it, and I want to show you doing it all the way from the beginning with your graphing calculator so you understand what part of the table you should probably write down. I'm going to go to my y equals screen. I'm going to go to math and head over to number and pick number 1, absolute value, and I will type in x minus 5. I will hit zoom 6. Okay, in order to get a picture of my graph, and then I'll look at the table of values by hitting second graph. Now we want to take a look for where that turning point is going to happen because we know an absolute value graph now has a V shape. So if I again scroll down, I see this pattern where I go 3, 2, 4, 1, 5, 0, 6, 1, 7, 2. So I can tell that my turning point is right there at 5, 0. So we definitely want to make sure that that goes in the middle of the table and we build out from there. We have x and g of x. Then we have 5, 0 that has to be in the center. So that's right here. This is the turning point. And I showed you how to find that on the graphing calculator. Then we can go from there, 6, 1, 7, 2, 8, 3. Those are coming directly off the graphing calculator. And above it, we have 4, 1, 3, 2, and 2, 3. So that entire table of values comes exactly from your graphing calculator. It is not something that you have to plug the numbers in, find out what they are, and then evaluate. So from here, we can just come over and graph this. We have 2, 3, 3, 2, 4, 1, 5, 0, 6, 1, 7, 2, 8, 3. So now we see we have this V-shaped graph like so. and we will label it with g of x equals the absolute value of x minus 5. And that concludes your lesson on absolute value, day 2.